All right, we are back. Now, it's possible when you're doing research that you're actually interested in aspects of the participant serving as independent variables. These are, on this chart, it says internal variables. In some research methods books, they'll call them subject variables because they're things that are inside the subject. The key thing is that these are characteristics that the participant brought with them. And if you use those characteristics as an independent variable, you're basically sorting them into the groups that they already belong to. So for example, if you use age as a variable, you're going to be sorting people into group based on something that they already possess. They are whatever age they are. So maybe you put all the 18 to 22-year-olds in this group and all the 22 to 25-year-olds in this group and so on, right? They're already in those groups. Sex is another really good example. So a few slides back, a couple of lectures ago, I showed you keeping it simple and showed you a pretty complicated design. And you might have noticed age and sex were on the list. Those aren't variables that I can manipulate, right? Those are participant characteristics. Those are things that the participant brought with them. And we're going to use that. And we treat them as if they're independent variables, but they're not real independent variables. We can't manipulate that. And that's important because as soon as you start using any participant characteristics, you lose some of your confidence that you know why the independent variable affected the dependent variable in the way that it did. If we discovered, for example, that males and females scored differently on some dependent variable, it might be the sex that they are that determined their difference in performance, but it might be all the other stuff that goes along with sex. Right? The socialization that people got, the internalization of messages, all these things go along with being male or female, that any one of those things might be more important than the actual biological sex, right? And so we never really know whether the subject variable that we're using is the factor that's important or if it's all the other things that go along with that. So we can't be as confident. From studies that include participant characteristics as independent variables. Now, having said that, it's really common in psychology to use those. A lot of things that we're interested in are participant characteristics. So we sort people by sex, or we sort people by whether their parents are still married or not, or we sort people by whether they've ever been treated for alcoholism, or all sorts of things. We like to study things that involve these kinds of participant characteristics. So it's one of the reasons why psychology gets criticized for being a softer science, because we do use characteristics that are a little bit muddy, right? We don't know that really caused that, is what we're saying. All right, back to our two-group design. So how do we go about randomly assigning our participants to group when we really do have control over the variables? So how do we randomly assign? Well, this is a good example. We can randomly assign by putting everybody's name in a hat. Or, you know what they oftentimes do in research studies is they'll have maybe their goal that they're going to have 30 participants in this study. And they want 15 of them in one group and 15 of them in another group. So they'll put 30 slips of paper, numbered either 1 or 2, into the fishbowl, and every participant who arrives draws a slip of paper out, and that's how they learn which condition they're in, 1 or 2. Are you in this group or that group, right? And so it's a random assignment. It's almost an equal chance of being placed into either group. It's not perfect because the first person who arrives has 30 pieces of paper, the next person who arrives has 29, and so on. So by the 30th participant, their fate is sealed. They're going into that one condition that's left. But it's a good way to, without any intention, without any kind of bias, you can place your participants into groups. We want every participant to have an equal chance of being in either group. That's the goal. It's not perfect. It's really hard to actually implement randomness in a way that truly is random. It really is. And so we do the best we can. Keep in mind, I'm not talking about selection. A lot of students really, I'm going to beat this to death. And those of you who have already separated in your mind are like, why do you keep saying this? But a lot of students mix up selection and assignment. I'm talking about random assignment. Now, here's a really important fact to keep in mind. it takes at least 20 participants in order for random assignment to work. So here I have a case where they had 53 eligible patients. 23 of them were not included in the study because 13 said, oh no, I don't want to do your study. 5 had a bad echo, 2 had atrial fibrillation, 1 had a valvopathy, 1 died, and 1 was pregnant. Okay, so of the 53 eligible, we ended up with 30, and 20 of them got carvedilol, which is a heart medication, and 10 got a placebo. So you might be thinking, why didn't you assign 15 and 15 if you had 30 randomized patients? Well, if you're at a particular stage in your drug trials, you are starting to already realize that carvedilol is working, and now you're trying to figure out whether it has untenable side effects. And so you want more people taking it so that more opportunity for the side effects to emerge is provided. You still need some placebo controls though, because you want to still be able to make arguments that there were more side effects or not in the carvedilol condition than in the placebo condition. So you still need a placebo, but you want to give the best benefit to the participants as you can. So give more of them the treatment that you're already knowing is working, and then also give the best chance to reveal the dependent variable, which in this case would be the amount of side effects. So the important thing is the randomization, not the total number that's going to result in each group. And you might think to yourself, isn't 10 placebo too small, or isn't 20 carvedilol, isn't that too small of a sample? But if you have at least 20 total participants, randomization will effectively work to distribute the individual differences between the groups. And 20, like 10 people per condition, is enough power for the t-test, which is the statistic you would use for this kind of analysis, to produce a significant outcome if there is in fact a difference between the groups. It might even be a little overly sensitive, and it might return a report that there's a significant difference between groups if there's too many people in the study. If you're doing a t-test and you get to more than about 50 participants per condition, you kind of blow out the statistic and everything comes back significant. Like the only thing now that would be meaningful is if it came back non-significant. You'd know that it's really not significant if a t-test with 50 people per condition comes back non-significant. So t-tests you can keep really small. When I do research on memory and use a t-test, I typically go for 15 participants per condition. So we have this random assignment. It allows us to form independent groups. It allows us to conduct what are called between subjects comparisons. So we can compare those subjects who got carvedilol to those subjects who got a placebo. So those are different groups of people. We call that a between subjects. The comparisons are being made between the participants. The big goal, the whole reason why I want you to memorize your random assignment issues, is because this is the strategy that allows us to distribute individual differences between the groups. If you don't use a random assignment, we can't be sure that the group started out equal, that they, if we were to give them a pretest, they would have scored the same way on the pretest. You don't have to give a pretest if you've used true random assignment. That's the key thing. All right. So random assignment produces equal groups in the long run. Luckily, in this case, having only 2 groups, the long run isn't very long. It's only about 20 participants. If you have at least 20 participants, it'll work. The larger your group, generally the more confidence you can have, up to that sweet spot of about 50 participants per condition, when now you have to start doubting, man, is everything just coming out significant because I've got so much power? Because this statistic is so sensitive to even the smallest amount of change once the N gets so big. So you want to have probably something between 20 total participants, so that's like 10 per condition, and 100 participants, about 50 per condition, if you're going to do a 2-group design, which is nice. That's very economical. You can conduct studies with smaller sample sizes, which is nice. In a lot of scenarios, we don't have that many participants available. So it's really nice to have a technique that allows us to have very confident outcomes, even though we have smaller samples. So it's a big advantage. Keeping it simple is key. So what if there are not that even 20 potential research participants? Maybe because what you're studying is pretty rare, or because where you work doesn't have that many participants available, or something like that. So what if there aren't that many participants, and even if there were, random assignment might not create equal groups? What if you have some reason to believe that you may not end up with equal groups through the random procedure? Well, luckily, we have other methods available to us. So let's go ahead and take a break, and we'll come back and talk about non-random assignment.